All right, guys. We're going to add to our notebooks. I'm actually going to do this in two separate videos, but we're going to be talking about special right triangles. We're going to be doing that on page 75, 76, 77, and 78. So lots of good examples. So when it comes to special right triangles, there's actually two types. In this video, I'm going to talk about, on page 75, our 30, 60, 90 special right triangle. Okay, so actually before I even have a right triangle, if we're looking at an equilateral triangle, something that I know about it is that all the sides are equal or congruent. Excuse me. So all the sides are the same. The other important thing to remember about an equilateral triangle is that all the angles are the same. And specifically, they're all equal to 60 degrees. So we can show that they're all the same by doing our rainbows in each corner. But I also should keep in mind that they are each 60 degrees. Now, the interesting thing that can happen with an equilateral triangle, because again, this whole chapter is about right triangles, not equilateral ones. However, if I draw an altitude, which is from an angle down to a side perpendicularly, I end up getting two right triangles where I can know a little bit about these. So taking a look at just one of the right triangles, I mean, they are congruent to each other, so it doesn't matter which one. If I take a look at that right triangle right there, when you drop down that altitude, not only is it 90 right here, but it also splits this side in half equally, and it splits your angle in half equally. So now I'm looking at a 30 degree, 60 degree, 90 degree right triangle. That's why we call it a 30, 60, 90. And the reason that it's special is because unlike the Pythagorean theorem, where I need to know two sides to find the third, I really just need to know one side here, because with an equilateral triangle, if all the sides are x units long, I now know this bottom edge is going to be half of x because I split it in half. And then I can find the altitude by doing the Pythagorean theorem. So if we label the altitude with A, side A, altitude, to find the length of the altitude, we want to do our Pythagorean theorem. So the two legs squared plus or equals the hypotenuse squared. So a squared plus half x squared equals x squared. So if I square all the things, so a squared is still a squared, but half x squared is 1/4 x squared. And then if I want to find the length of the altitude, so solve for the altitude, I would want to get a alone. So subtract that 1/4 x squared on both sides. And so I have a squared by itself. And these are like terms because they're both x squareds. And there's one of them here, minus a fourth for 3/4 x squared. And then I square root both sides to get a completely alone. And then I just need to square root each thing individually. So the square root of 3 I don't know. I'm going to have to leave it square root of 3. The square root of 4 I do know. That's 2. And the square root of x squared is just x. Now to write this a slightly better way, what I have is half of x, and then a root 3 would be the altitude. And that's good to have them all in terms of x. And what actually makes this even better to look at is if I take that right triangle down there and scale it up a little bit. So we got our 30 here, our 60 here. If I scale it all up by 2, then I won't be looking at nasty fractions. So if I times each of these sides by 2, so I'd have 2x, x root 3 That helps us to see a pattern here. So every single time I just need to know one side and I can know all the other sides. So an important thing to keep in mind is that across from 30 is the shortest side, or I like to call it a short leg. Across from 60 is the long leg. And then across from my 90 is the hypotenuse. So those are important to keep in mind. So here's how the pattern goes. And we're just going to do a whole bunch of them. Again, if I have my short leg, long leg, hypotenuse, those were the lengths that we had just found on our 30, 60, 90 triangle. And if I know that x happens to actually be 5, so I know that the short leg of my right triangle is 5 units long, I can know the rest of them just by following the pattern. So your long leg would then be 5 root 3, and your hypotenuse would be 10. And you can go the other way too. So this is if I go from shortest to hypotenuse. If I know that the hypotenuse is 12, well, the short leg will be half of that, so 6. And then the long leg is 6 root 3. Oop. Or if I know the long leg, let's say that the long leg is 2 root 3. Then the short leg is just 2, and the hypotenuse should be 4. So we can go that way as well. What else? A trickier thing to do is when your hypotenuse is not super nice. So like if my hypotenuse was 17 units long, so I say that that's not nice because like when I went from hypotenuse to short, I had to take half. And I can't really take half of 17. So I'm just going to write 17 over 2 because you know your girl hates a decimal. And then when I go from short to long, I'm really just putting that root 3 on it. So 17 over 2 root 3. Okay. Or another way to go is like if I knew that the short leg was 9 over 2, then the long leg is 9 over 2 root 3. And your hypotenuse is 9. Okay. So if it's odd, it's not so bad. The worst case scenario is that your root 3 is in the wrong spot. So really when we're following this pattern, the root 3 always shows up on the side opposite the 60, so the long leg, but it doesn't have to. And so if it doesn't, that kind of goofs things up a little bit. So let's say, for instance, we had 33 as that long leg, which that's different than all these other ones because they all had a root 3 on it. And like when I was going back to this one, I was kind of just like taking the root 3 off. But like taking a root 3 off isn't really a mathy thing to do. Really what you're doing there is dividing by root 3. And now there's this pesky little rule in math. So if I take that 33 and divide by root 3, I can't divide those because one is outside the root, one's inside the root. And the other pesky little math rule is that you are not allowed to leave roots in the denominator. So we can do this process called rationalize the denominator, where I just really multiply by 1. So same number on top, same number on bottom. And the number you want to pick is whatever is in the bottom. So root 3 over root 3. And the reason that that will work out is because on the bottom, when I do root 3 times root 3, that's root 9, which is 3. So the root goes away, which is what I needed to do. Now on top, I can't really times those. We just smush them together. But then I can divide these numbers outside, and so you end up with 11 root 3. Okay, so that short leg is just 11 root 3. And then when I double it to get the hypotenuse, we just double the outside, so 22 root 3. So kind of the thing that happens here is really I just take a third and put a root 3. Or kind of the way I like to think of it. So again, if this number here is like 18, there's got to be a root 3 somewhere because there's always a root 3 in the pattern. And if it's not where it's supposed to be, which is on the long leg, then it's going to be in the other two places. And so I just think, what times 3 is 18? And that's 6. And then I double it for 12. So another example of that could be like, if this is 9, that's where the root 3 is supposed to be, and it's not. So this has got to be root 3, and 3 times 3 is 9. So 3 root 3. And then double it, so 6 root 3. So lots of fun ways that we can do that. Doing some of these examples over here, it's kind of good to do some on a triangle because you need to know which side you're looking at. And so it's all about what you're opposite of. So looking at this one first, I know I skipped that one, but looking at this one first, the side that I know, the 7, is the short leg. And I know so because it's across from the 30-degree angle. So this is the long leg, and this is my hypotenuse. And that's important because if I'm going from short leg, everything needs to get bigger. The long leg gets bigger by root 3, so 7 root 3, and the hypotenuse gets bigger by doubling. So like when I'm going from here to here, I times by 2. Then I go from here to here, I'm like putting a root 3, but kind of times in a root 3 because putting a thing isn't really mathy. Okay, so if we go to the one under, the side that I know, 12, is my long leg because it's across from the 60. This guy over here is my short leg, and then my hypotenuse. So my long leg is typically where the root 3 is supposed to be. So since it's not, it's going to be on the other ones. So really when I'm going from here to here, I'm dividing by root 3, but I'm just kind of putting a root 3 and thinking 3 times what is 12? So 4. And then when I go from here to here, I want to double it. So 8 root 3. This one next, I know the hypotenuse. Y would be the short side because that's across from 30, and this is our long leg. And so I think it's easiest to go from hypotenuse to short because we just take half. So that's 10. And then I go from here to here by putting a root 3 or times by root 3, so 10 root 3. And then the last one that we have here, and the reason I wanted to save this for last is because I said there always has to be a root 3, and that's kind of a lie. Like typically the pattern follows a root 3 thing, but if you start introducing other roots, then stuff loses the root 3. So in this triangle here, this is the short leg because it's across from 30. This is our long leg. This is our hypotenuse. Now short to hypotenuse, I always just double it. So like that's not so bad. That'll be 8 root 2. So like when I double it, I really just multiply the outside number because these are both outside numbers. Now when I'm going from short to long, we're like putting a root 3. But kind of the mathy thing is really timesing by root 3. And so we're actually not going to times the 3 by everything. Since it's inside, we're just going to multiply it by the inside number. So we'd have 4 root 6 for that one. So jumping ahead, because page 76 has our other pattern, we're going to do that in a different video. If we take a look at our 30, 60, 90 on this side, if this side is n and this side is 2n, I like to call this one n root 3. Okay, so x, double x, x root 3. So if I'm going, and these are like all of our shortcuts right here. So if I'm going from the short leg to the hypotenuse, we want to times by 2. If I'm going from the short leg to the long leg, we want to times by root 3. But usually that just looks like putting a root 3 on. Okay. When we go from that long leg to short leg, when we go backwards, we just do the opposite. So we divide by root 3. But because we have to rationalize, really what ends up happening there is we take a third and then put a root 3 on. Times by root 3. Let me just go backwards. When I want to go from the hypotenuse to the short leg, we take half. So we're just going backwards. And then if we got to go from hypotenuse to long leg or long leg to hypotenuse, basically you want to do that intermediate step. But Because if you're going from the hypotenuse to the long leg, you got to take half and put a root 3. And if you go from long leg to hypotenuse, you need to double and divide the root 3, or kind of take it off. I normally don't travel from long to hypotenuse. I always just get the small in between because I find that to be too tricky. So if we try these ones out under here, I always like to first identify what sides I have. So across from 30 is the short, across from 60 is the long, across from 90 is the hypotenuse. So I know that the short side is 4. I want to double to go to the hypotenuse and put a root 3 to go to the long. On this next one here, we got across from 30 is the short, across from 60 is the long, across from 90 is the hypotenuse. So I know that the hypotenuse is 10, so the short will be half, and the long will be root 3 times as much. Okay, on to the next. I have the long leg here, short leg there, hypotenuse here. So since the long leg is 4 root 3, the short will just be 4, and then the hypotenuse is double as much. Oh my goodness, that's the same one. Next, on this guy here, I know that the hypotenuse is 13. This guy's the short, which I'm going to find next. It's going to be half as much, so 13 over 2. And then that long leg will be root 3 times as much, so 13 over 2 root 3. Now let's get some weird ones. So down here we got across from 30 is the short, across from 60 is the long, across from 90 is the hypotenuse. So I have the long, which is like where the root 3 is supposed to be, and it's not. So going backwards, I need to divide by root 3. So that's going to look a mess, like 2 root 5 divided by root 3. Like it's not even good. Got to times by root 3 over root 3 so that we can rationalize. Bottom will be root 9, which is 3. On the top, we'll have 2 root 15. Ugh. So 2/3 root 15. And then when I go from short to hypotenuse, I want to double it. So I just times by 2. So 4 over 3 root 15. Super yuck. And then on this last one here, we got the short, we got the long, we got the hypotenuse. So the short here, when I go from short to long, I want to times by root 3. So that'll be 3 root 6, because we just do the inside numbers. And then when I go from short to hypotenuse, I just want to double it. So 6 root 2. Just multiply the outside numbers. So 3 and 2. Oh my goodness. Okay, good. We're going to leave it there.